Let's look at example 4. The numerical population of grade point averages at a college has mean 2.61 and standard deviation 0.5. If a random sample of size 100 is taken from the population, what is the probability that the sample mean will be between 2.51 and 2.71? Now notice we're talking about the probability of the sample mean. So that's the probability of x bar and not x. We also have a sample size that is large, and so that tells us that our sampling distribution is normally distributed, and we can use our z-score. All right, so let's take 2.51 and 2.71, and we're going to put them into our z-score formula. But first, we must identify the mean of the sampling distribution and the standard deviation of the sampling distribution. All right, so recall that the mean is the same as the population mean of 2.61. So we can go ahead and write that out. I'll just sort of ignore this and move it down so we don't see it. So the mean of x bar is equal to, in this case, 2.61. Oops. And then the standard deviation of x bar is equal to our population standard deviation of 0.5 divided by the square root of 100. So if we put that into our calculator, that's going to give us 0.05. All right, now that we've got these two things, let's go back here for a moment, and we want to find the probability that our sample mean is between 2.51 and 2.71. All right, so let's start with 2.51. All right, so recall our formula. If we're using a sample mean, is the sample mean x bar minus our population mean mu, or in this case the mean of x bar, divided by sigma divided by the square root of the sample size. All right, so let's fill in. We had to begin with 2.51. So we want to put 2.51 in, and then we'll put 2.71 in. So 2.51 minus the mean of x bar, 2.61, divided by, well, we've already done the calculation of sigma divided by the square root of the sample size, so we don't need to do that calculation again. Let's just put 0.05 in the denominator. All right, so now we have negative 0.10 divided by 0.05. And let's stick that into the calculator. And that gives us negative 2. All right, now we also need to do our z-score for 2.71. Exactly the same calculation except for the 2.71, which is going to give us a positive 0.1 over 0.05, or a positive 2. So now we need to look up our two z-values using Excel, and then remember, since we're looking for the probability of it being between these two values, we're going to subtract those two probabilities. I'm going to put the 2 in first because it will be the bigger probability. All right, so I'll go in here and just ignore all that. Equal norm.s.dist. Let's put 2 in and true, and that gives me 0.9773. All right, so 0.9773 minus, and now let's look up negative 2, equal norm.s.dist, and we want negative 2 and true, and that is 0.0228. All right, so 0.0228, and if we put that into our calculator, we end up with the probability 0.9545. And there we have it. So remember, with these problems, the first thing you always want to get is the mean of x bar and the standard deviation of x bar, and then we can plug it into our formula.